Even for the cemented carbide, P code and the blue color, it is for the machining of the long chip formation. Common material like plain carbon steel or the low alloy steel. M is the code and the yellow is the color for machining and the long or the short chip formation. Ferrous material like stainless steel. K is then red is for machining the short chip ferrous, non-ferrous material like cast iron and the brass. So these are the color coding and the IA international standard coding. Next one is the plain ceramic. Next one is the plain ceramic. So basically the plain ceramic are consist of the aluminium oxide या alumina भी बोल देते हैं and the silica nitrate and the silica nitrate. So इनका main benefit क्या होता है? They do not react with the workpiece. They do not react with the workpiece. And the ceramic cutting tools are very hard and they also produce the high hot red hardness during the cutting operation and do not react with the workpiece. They can be used as the elevating temperature and cutting speed is 4 times more than the cemented carbide, having the low heat conductivity. So, inherently, the high compressive strength, chemical stability, and the hot hardness of the ceramic led to the pot. Again, they are produced by the powder metallurgical process, and they are produced in the form of the inserts. तो ये cutting tool है किस form में बनते हैं? They are used in the form of the inserts. ये मैंने first chapter में भी आपको बताया था inserts क्या होते हैं? ये होते हैं inserts. These are the inserts. ये देख रहे हो diagram? So these are the carbide inserts for turning and the milling operation. This diagram. This one. And these are the threaded inserts which are used to produce the threads in the plastic. So इनको हम क्या करते हैं? जो आपका कटिंग टूल होता है, कटिंग टूल के टिप के ऊपर उनके टिप के साथ हम क्या कर देते हैं? क्लैंप कर देते हैं. जो रेक फेस होता है उसके साथ ही हम ऊपर क्या कर देते हैं? इसको क्लैंप कर देते हैं. So कटिंग ऑपरेशन सारा यही करते हैं. So these are the threaded inserts for the plastic and these are the carbide inserts for the turning and the nowadays जहाँ भी high speed cutting करनी है, high precision cut machining करनी है, तो वहाँ आजकल हम क्या use करते हैं? We use all these types of the inserts. इनको हम inserts बोलते हैं. ये insert किसके ऊपर use करते हैं? जो आपका cutting tool होता है, जैसे high speed cutting tool है, उसके ऊपर ही इसको हम क्या कर देते हैं? Clamp देते हैं. They are clamped on the high speed steel cutting tool. या weld कर देते हैं, उनके साथ ही हम इनको क्या कर देते हैं? They are welded. And then जो HSS वाला जो tool होता है, उसको फिर हम tool holder के अंदर fix कर देते हैं. This one is a plain. These are known as the plain ceramics. The advantage इनकी दी हुई है. Advantage and disadvantage. Advantage is produces the very high hardness, very high hot hardness, chemical stability, anti-welding, less diffusivity, high abrasion resistance, high melting point, low thermal conductivity, low thermal expansion of coefficient. So shortcoming क्या? Poor toughness, poor tensile strength, poor TRS. TRS check करना पड़ेगा बेटा क्या है? And the low thermal conductivity and the less density. So alumina is preferred to the silicon nitride for higher hardness and the chemical stability. So the silicon nitride is tougher but again more difficult to process. So the plain ceramics are brittle in nature and hence has a limited application. Generally क्या होते हैं? ये brittle in nature होते हैं, इसीलिए इनकी poor toughness होती है, ये एकदम टूट जाते हैं. So basically again there are the three types of the ceramics. There are three types of the ceramics too. one is plain aluminium with the trace of additive, without the additives, and the carbide ceramics, and the carbide ceramics, and the carbide ceramics. So first one is plain aluminum with the trace of additives. If trace of additives में क्या layers की form में होता है. So these are basically white or pink in the color, and again they are in the form of the inserts. Again they are produced by the powder metallurgical process in which the mixture is cold pressed. The mixture is cold processed and are used for machining the cast iron, and the similar material cutting metal removing rate or the speed is 200 to 250 meter per minute. Aluminium with or without the additives, they are hot pressed, black in color, harder, strong, and used for the machining of the steel and the cast iron, and the cutting speed is at 150 to 250 meter per minute. Again, carbide ceramics, they are the mixture of the aluminium plus 30% of the titanium carbide. They are again cold and the hot pressed, black in color, having the good strength, again used for machining the cast iron, and the plain alloy steel at a speed of 150 to 200 meter per minute. However, the use of those brittle plain ceramics until their strength and the toughness could be substantially improved since 1970, but they gradually decreased because of following the following reason. इसका मतलब ये है लाइन का कि जो ये प्लेन सेरामिक्स टूल्स थे, फर्दर इनमें हमने स्ट्रेंथ भी और टफनेस भी हमने इनकी इंक्रीज की, बट ये धीरे धीरे इनकी जो इनका यूज है इट वाज डिक्रीज बिकॉज ऑफ दे आर restricted to only for these four reasons. One is the uninterrupted machining of the soft cast iron and the steel only, relatively high cutting speed, but only in the narrow range, that is in between only 200 to 300 meter per minute. Advent of the coated carbide capable of machining but they were only used for machining the cast iron and the steel at the high speed. So these are the only two reasons. एक तो ये soft cast iron और steel के लिए